Okay, today's little video is on the surface grinder. My name is Alistair. You've seen a few of my videos, I guess. I've stuck a few up for myself so I can remember what I'm doing. So today I'm going to record some work on the surface grinder. This is a Churchill NB surface grinder. It's got some parts missing. I've made some parts for it to make it go again. I'm not entirely happy with the parts I've made, but they'll work. So this is a little video of the bits and pieces and how it goes together. This is the cross slide, or Y-axis I guess you'd call it, that moves the work in and out across the grinding wheel. It's not the left to right motion, it's the in and out motion. And it's normally automatic, but on this machine it's all broken and parts missing. So I've repaired it and replaced some of the missing parts. There was a nut missing, a little lever missing, a sort of T-clamp assembly on the bottom that was missing, and it's quite a tricky little thing to get back together properly. But I'll do a little video of the parts. And it's had a new bearing. The bearing in it, which was one of these angular contact bearings, was finished. Very bad condition. How it got that bad, I have no idea. It's only sat in a grinder which is in oil, but anyhow, it didn't work anymore, so it had to be replaced. Or it was very rough. So that's the little explanation of what we're going to do this morning, today. Try and get this surface grinder back together and working. Okay, this is the parts. This is the main shaft here. This is the bearing we had to replace in there. These are some lock rings. Here is the final ratchet assembly, and this is the selector that goes on the shaft, and this is the hand wheel, and we've got to put all this back together in the grinder and make it work, basically. So I'll be getting on with that. This bearing in here, by the way, is an angular contact bearing, just for my records so I know if I ever need another one. Also fits the 6307, same size bearing, fits the Land Rover gearbox, but it's not an angular contact, it's just an ordinary radial roller ball race. This is where it goes, and there it's a little bit greasy and dirty, but that's where it goes. This here, down here, is the mechanism. That's the little T-bolt assembly I had to make. This is the little lever assembly I had to make to operate the selector, or the slider on the shaft. And today I'm going to be putting some pins in this, firm it up, and this can go back in. I might do a little bit of filing on here, round the corners off, but it works fine as it is. There's not much need to do anything to it. It's perfectly functional. Okay, this is our little job here. We've got to put some pins in this block because there's no pins in it and there's no reason to stop these turning. So we've got to find the centre of the block, find the end of the block, and these two pins are 1 3/4 inches apart and they're 1.5 inches from the end. So just find the centre. It's pretty easy using the normal method, DRO and a wobbler. Again, doesn't have to be terribly precise. Just be 3/8 of an inch to the centre. Yes, it's 3/8 of an inch, not half an inch. There we go. Yep. So these are 3/8 of an inch from the end of the block. Little centre drill. Pins are going to be 1/8. Little 1/8 pins. Welding wire basically. I want them to be a fairly tight fit, so I'm going to use a pilot drill and then a 1/8 drill. Now, cutting speed for these drills. That's 332, which is 3/64 radius. .32 times pi divided by 12 is 40.74 times 50 feet per minute. About 2000 RPM. And that small drill. I generally run about 50 feet per minute. Which gives that 2000 RPM. In a deep hole like this, good idea to clear the chips out. Let's see what the speed change is on 1/8. 0.125 times pi. 0.3 divided by 12. Is 7.55 times 50 equals 1500 RPM for a 1/8 drill. Dribble down, around about there. Okay, next hole. Just 1 3/4 inches further along. Set the DRO to 0 on the x-axis and just go along 1 3/4 inches. Right spot. Okay, now I'm going to drill the final 1/8 hole. Okay, that's that. I'm now going to just put a couple of pins in. And that'll be that job done. Okay, what we've got to do here is put some 1/8 pins. I haven't got any 1/8 rod, but I've got some 1/8 welding wire which will go in here, so just want some soft iron wire. So knock the flux off, give it a bit of a rub with some emery paper, and there we go. So, just going to cut a lump of this off. little bit sticking out the other side for now. Saw that off. Junior hacksaw. Need about a 1/16 of an inch for 8th wire to pull my rivet head and squish it down in the hole. So to make the wire swell, what we do is just whop with the hammer. Pretty well it done. Take a file and just file it off. Put it flush with the surface. Pretty well disappeared. You can probably see it's now gone. And there's the other side. Now many people will say you should use the keen end of the hammer for riveting, but this kind of riveting I've always found the flat end does a better job. Just swell the rivet up so it swells into the hole and the head mushrooms a bit, and file it off and virtually disappears. One more. There we go. About a 1/16 of an inch from the end. And there we are. Visible riveting. Disappeared. Gone. But pinned on. So they won't be moving again in any great hurry. Now what we have to do is put it all back together. Okay, here we are. This is looking inside. I've got the shaft back in. What I think is the top is the top. I've got a special little tool here which I'm going to use to put the screws back in. So there it is in there with the little arm that I've made, and now I'm going to put the slider in there. So you can see how it all goes together. Okay, that's the sliders now in there. Focus on it. That's in there, and there's the arm engaged in the groove. There's a little, trying to show it here, a hole there which a pin has to go in. A little dowel just there. So a little dowel has to go in there, and then the next ratchet mechanism goes on. Well, here we are, got the old Churchill surface grinder going at last. There he is, the wheel's actually spinning round. There we go. There's the wheel. That's the hydraulic pump. Switch it on. Going backwards and forwards. Fortunately, hitting the old compressor at the moment, which it doesn't like very much, but there we are, there it is, going backwards and forwards. And what was wrong with it was this auto feed here, or this little mechanism here, would not work. So now it does. And there it is, going all by itself, which keys the table in, and if we flip it up, it goes the other way. And that took quite a lot of work to get to that stage. Going fine and reasonably accurate, within a few tenths over a few inches, so still needs truing up a little bit, but not too bad. So that's the grinder. Finally that's going. Had a few little electrical issues with it. Kept blowing the trips, but that turns out it's largely because it's been converted from 480 volt to 220 volts, so now the current is too high. Anyway, that's kind of fixed that. So that's the little surface grinder going at last. Then on to the mill. Here's the mill. Now we've been doing a few things to the mill. Well, we've got this to fix yet. Still to hold on somewhere. Most of the work has been fitting this lever here. This is the spindle lock. This here, this knob, and so on here, which is the trip for the feed. This lever here, which was missing. Now this wheel was missing, along with its graduations. So that was what was missing off here. So now the feed is all functional and it feeds all down by itself. So if we engage the feed, use a high speed one. I'll put engage the actual spindle mill. I'll have to put the camera down. There we are, the spindle's engaged now. So there it is. And there's the auto feed going down. Going round, and then if I engage it, you can see the spindle is going down fully automatically now. That would be good for drilling holes, as it were. Got different speeds. That's the medium speed. Goes back to high speed. Back to low speed. There it is. Well, it's come to a stop now. So that's that all working. A little digital readout on here. That's all functional. So all we've got left to do now is fix the locks here. The locks are missing, so I need to make some locks for it and get this thing. That's 3 thou per rev, 6 thou per rev, and 1.5 thou per rev, which is pretty common for these machines. The other machine I had exactly the same feed rate. There's a thing called a First. I think it's a Taiwanese milling machine of some sort. Anyway, it kind of works. That's all we really need it to do. Anyway, I'll do a few more videos of these things as and when there's something to show. And that's about it for now.